Hello friends, I welcome you in lecture number 14 on hypothesis testing. In this lecture, we will discuss one more question on two sample t-test. This question was asked in GTU summer 2021 exam. Now we know that we have two situations in two sample t-test. One situation is that population variances are equal and another situation is they are not equal, and in both the situations we have different statistic for testing the null hypothesis. If we have equal population variances, then t statistic is x bar minus y bar minus mu1 minus mu2 divided by pooled standard deviation times 1 over first sample size plus 1 over second sample size. And in the case of unequal variances, we consider this formula for t statistic x bar minus y bar minus mu1 minus mu2 square root of s1 square over n1 plus s2 square over n2. Here degrees of freedom are n1 plus n2 minus 1, and here we have big expression for estimated degrees of freedom, and that formula for estimated degrees of freedom is big expression but easy to remember. Here we write s1 square over n1 plus s2 square over n2 square of these two. In the denominator, we have 1 over n1 minus 1 into square of this first term. First term in this bracket is s1 square over n1. So we take square of this first term, and same thing for another sample n2 minus 1 square of second term s2 square over n2 whole square. And whatever answer we obtain, that we round down to the nearest integer, and here we are using pooled estimator of population standard deviation, and formula for that pooled standard deviation or pooled estimator of population variance is n1 minus 1 times sample variance for first sample plus n2 minus 1 times sample variance for second sample divided by n1 plus n2 minus 1. So with this in mind, we are going to discuss this question. And one more thing, if nothing is specified in the question, then we can assume that suppose equal population variances are there, or if we wish we can assume that population variances are different, and we can apply corresponding statistic for testing null hypothesis. The real method is, if you are not given any information about the population variances, then you can apply F test to check whether the population variances are equal or not. That we are going to discuss in future lectures. But to apply F test and then to apply t statistic for two sample t test will take much time, and process will be lengthy, and marks are not so much that we apply both the test and first we decide whether population variances are equal or different. So what we can do is, we can assume that population variances are equal and we can go for this formula of t statistic, or we can assume that population variances are different and we can apply this t statistic formula with estimated degrees of freedom. I have done this question using both the approach and I find the same conclusion, but that is not necessary that you will always have the same conclusion. That depends on mainly on this population variances. So with this in mind, we try to answer this question which was asked in GTU 2021 exam. Two salesmen denoted by capital A and capital B are working in a certain district. From a sample survey conducted by the head office, the following results were obtained. So there are two salesmen denoted by capital A and capital B, and these are the samples for their sales. For salesman A, number of sales are 20. For salesman B, they are 18. Average number of sales in rupees for salesman A are 170 rupees, and same for salesman B are 205 rupees. Standard deviation for salesman A is 20 rupees. For salesman B, it is 25 rupees. So these are the samples. Number of sales 20 sales for salesman A and 18 sales for salesman B. And from this information, we have to check whether there is any significant difference in the average sales between two salesmen. So suppose average sales of salesman A are denoted by mu suffix A, and average sales for salesman B are denoted by mu suffix B. Then we have to check whether there is any difference or they are equal at 5% level of significance. So first we have written this given data. We denote number of sales for salesman A by n suffix A, average sales for salesman A by x bar suffix A, and sample standard deviation for salesman A is denoted by s suffix A, and same thing for salesman B. And level of significance is 0.05 or 5%. Now we require some conditions for two sample t-test. If they are not given in the question, we can assume them. So I have assumed that two samples are random and independent. Also we assume that underlying populations are normal and sample sizes are less than 30. So we apply two sample t-test. And here we are considering that population variances are different. We are not assuming that we have equal population variances. So this is the situation that population variances are different. So with this we consider this t statistic in the case of different or unequal population variances. And this is the null hypothesis. We want to check whether there is any significant difference in the average sales. Okay, the question is there any significant difference in the average sales between two salesmen? So null hypothesis is that there is no significant difference in the average sales between two salesmen. So it is in other form mu suffix A equal to mu suffix B. This is null hypothesis, and alternative hypothesis is these two are different, that is mu suffix A is not equal to mu suffix B. And we are performing the test under the assumption that these two are equal. The level of significance is 0.05. Test statistic is in the case of unequal variances. We have this formula for test statistic, and it is denoted by T dash x bar A minus x bar B minus mu A minus mu B divided by square root of S A square over NA plus SB square over NB. And we assume that null hypothesis is true, that is we have mu A and mu B equal, therefore this quantity is 0, and we substitute values of all these quantities from the given information. We are putting all these values NA 20, NB 18, and sample means are 170205, and standard deviations are 20 and 25. We substitute all those values in this formula. Average sample mean for salesman A is 170, salesman B is 205. Sample standard deviation for salesman A is 20, and here we have to square it. For salesman B it is 25. Here sample size is 20, here it is 18. And using scientific calculator I find that value of t dash is minus 4.7314. In the next step, I have to decide critical values of this t statistic, t test. So for that, I require estimated degrees of freedom. So I have to use this big expression for estimated degrees of freedom, because I am taking the assumption that these two are unequal. Estimated degrees of freedom are given by this expression. We have SA square over NA in this expression, and if you can see here, I have already calculated these quantities here. SA square over NA, that is 20 square over 20. So I can directly put SA square over NA equal to 20. Similarly, SB square over NB is 34.7222, that is here. So from this we can directly put these two values in this expression. So I have written those two values from those earlier calculations in this expression, and this is also there, square of this term plus square of this term. NA is 20, so we have 20 minus 1, that is 19. NB is 18, so here we write 17. And using scientific calculator, we find this estimated degrees of freedom equal to 32.5590. But we round down to this integer 32. Therefore, estimated degrees of freedom are 32. And now we can find out critical values using t table. Now we have estimated degrees of freedom, that is 32. Level of significance is 0.05, and alternative hypothesis is that these two population means are different. That means we have two-tailed test. Therefore, we divide this alpha into two areas of 0.025. So if you recall, this is the shape of t distribution. It is bell-shaped curve, and we are interested in these two critical values. The area in both the tails is 0.025. So we are interested in these two values, t suffix alpha by 2 and minus t suffix alpha by 2. And here we have t equal to 0. And we have 32 degrees of freedom. So alpha by 2 is 0.025, that is 2.5%. Area is in one tail, and in both the tails we have 5% area. So now we consider that t table, and we find out this corresponding values from the t table. So I have to look under this 5% and 2.5%, because I have two-tailed test. So I have 2.5% area in one tail and 5% area in two tail, and I have to go up to 32 degrees of freedom. This column is for degrees of freedom, so I have to go up to 32 down in this column. So let's go up to 32. Here I have 32, and if I go up to this intersection is 2.037. that means the value of t is 2.037 for 2.5% area in one tail and 32 degrees of freedom. So that I have written here, that we find that t suffix 0.025 is 2.037 for 32 degrees of freedom. This value is 2.037, and this is negative of 2.037, and our value for t dash is minus 4.7314. So you can see this is minus 2.037 and we have minus 4 something. That means we are in the rejection region, and I have sketched systematically here also. You can see this is 2.037, this is minus 2.037. These two are critical values corresponding to alpha by 2 equal to 0.025, and these red line areas are rejection regions. Value of T dash is minus 4.7314, which we have calculated, and you can see it is in the rejection region. Therefore, we reject the null hypothesis, and null hypothesis is that there is no significant difference in the average sales between two salesmen, and we are rejecting this null hypothesis. That means we can conclude that there is a significant difference in the average sales between two salesmen. So fine, we have concluded using the assumption that we have unequal population variances. So this is the T statistic, and these are the estimated degrees of freedom. Now I have done the same question using pooled variance test. Here I assume that we have equal population variances for both the salesmen, so that I can apply pooled variance T test. So I have to write all these things. Assume that populations are normal and population variances are equal. Also assume that given samples are random and independent. These are the requirement to apply two sample T test. Then I have written this data for both the salesmen, and same null hypothesis and alternative hypothesis will be there. Level of significance is 0.05. Now to calculate the value of T statistic, we have to first find out pooled estimator denoted by SP square of common population variance denoted by sigma square. Here we assume that population variances are equal, and equal value is sigma square, which is unknown. So we estimate it using pooled estimator SP square, and this is the formula for pooled estimator. Easy to remember, we have written several times, and we substitute values of these quantities: sample size for sample A, sample size for salesman B, and their sample variances, and we find that SP square is 506.25 and its positive square root is 22.5. Once we have value of this pooled estimator, we can calculate T statistic, which is x bar A minus x bar B minus mu A minus mu B. This pooled standard deviation times square root of 1 over n into n suffix A plus 1 over n suffix B. Null hypothesis is assumed to be true, therefore these two are equal and therefore their difference is 0. Average sales for sample A are 170, for sample B they are 105. Pooled estimator is 22.5, and these are the sample sizes. And using scientific calculator, we find that value of T statistic is minus 4.7878. In the next step, as usual, we have to decide critical values. So level of significance is same, and we have two-tailed test. So we divide area into two tails. Here degrees of freedom are different: NA plus NB minus 2. First sample size 20, second sample size 18 minus 2. That is, we have 36 degrees of freedom. So now I have to look for 36 degrees of freedom in the T table. So let me remove this, and I have to look under this column. Two-tailed 5%, one-tailed 2.5%, and we have to go up to 36 degrees of freedom. In this column we are going up to 36 degrees of freedom. So you can see the intersecting point has value 2.028. So that is our critical value. I have written here from T table, T suffix 0.025 is 2.028, that is this value, and due to symmetry this point is negative of 2.028. So this area shaded by red lines are rejection regions, and area shaded by blue line is non-rejection region. Calculated value of T statistic is minus 4.7878, so it is in the rejection region. We can see that value of T statistic is less than minus T 0.025. So because we are in rejection region, we reject null hypothesis. That means there is a significant difference in the average sales between two salesmen. So I have done this question using both the approach or both the situations, that we don't know whether the population variances are equal or unequal. So we first assume that they are unequal and we apply corresponding t test, and in the second situation we assume that both are equal and we apply that two sample t test using pooled estimator. So this is all about this session. I hope you like it. Thanks for